Earthquake. To understand the earthquake analysis, we are considering one simple project. Ask. Just we will log in. We will get the full project online. Click anywhere on the screen, we will get the menu. For earthquake, we will select earthquake submenu, and in that we will discuss. In this plan, it shows center of mass and center of rigidity. The values, as you change the floor, the actual value should be reflected. In this submenu, to check eccentricity, plus you will get the eccentricity's value. In torsion, floor wise torsion you can see on plan. Now drift. Drift in X direction, drift in Y direction. You see the displacement of the structure, dotted line, and these are the values. Drift in Y direction, the values will be different. Now torsional shear X direction, you will get the values torsional shear. Torsional shear Y in the Y direction. How these results came, which we are showing on this plan and elevation, the full detailed calculations is here. As per IAS code clause 7.4, reduced live load are used for analysis, 0 on terrace and 50% on other floors if superimposed live load is less than 3. Accordingly, we have calculated the slab weight, then beam weight, column weight. Here we will get the total floor loads, equivalent total load floor wise. As per the data, seismic zone which we already selected in the project, seismic factor 0.16. Now earthquake loads in XX direction, this full calculation is there. Length of building in X direction, length of building in Y direction. Then building consists of a movement resisting frame and brick infill walls. So we have to calculate the natural period of vibration. As per IAS code, we have considered response factor R5, that is inbuilt. Importance factor as per the structure condition, type of building, it's considered 1. Seismic zone we already discussed, 0.16. coefficient, this design horizontal seismic coefficient, and accordingly horizontal shear on building in XX direction. Same way for the YY direction. Now here we have shown you earthquake horizontal load floor wise in XS and YY direction in this table. Now determine center of mass. Detailed calculation is there. Then to determine center of stiffness or center of rigidity, detailed calculation is there. Up to here we did analysis as per the coefficient analysis basis. Now from here dynamic analysis by response spectrum method in XS direction, similarly in YY direction. Mass matrix, stiffness matrix, eigenvalues that we have calculated as per the iteration, the eigenvalue we have got, and all these values are reflected in this tabular format. Calculation of model participation factor in XX direction. This table is self-explanatory. One should go through it and it will explain the modes. As per the IS code, number of modes up to 90% of the total value is considered, and further evaluation for the lateral load. So in our case up to mode 2. Now lateral load calculation by model analysis by SRSS method, that is tabulated in this. Second, lateral load calculation by model analysis, CQC method, by this metric. Now we have given the summary. Equivalent static method, lateral force and shear force. CQC method, lateral force and shear force. SRSS method, lateral force and shear force. Again, the final results from the different method of dynamic analysis in XX direction as per IS code. In this final table. Similar way we did the calculation for the YY direction. In this table we are calculating static eccentricity and design eccentricity of the building. Again, it is self-explanatory. Calculation of total shear in frame, direct shear plus torsional shear, X direction. Similarly for Y direction we have done. Calculation for direct shear, torsional shear and total shear at each column in X direction. That value we have calculated and displaying. Now the main design seismic force total deflection or drift of the frame. As per the IS code formulas, modulus of elasticity, the drift should not exceed 0.004 h, in other words 0.04% of the height, and that we have calculated frame wise floor wise, floor drift and displacement in x direction, dynamic analysis response spectrum method in xx direction, which we have already calculated. Now we are checking the stability indices. Stability indices we have calculated in the two tables. One as per the PU loads, as per the coefficient method basis. In that we checked whether it is sway or non-sway. Same way we have calculated the stability indices xx direction as per the seismic weight. Dynamic analysis. This is the way how we have evaluated the analysis and checked the stability of the structure. Similarly, for the y direction, again the repetition, full detailed calculation, one can check it. And at the last, same way, stability in the y direction of the structure. If any issue, just point out. We are here to comply that, and if there is anything wrong, kindly suggest. We will be thankful to you for correcting us. In this video, we have explained about the earthquake analysis for the small project in with detailed calculations. Thank you.